Hello out there, welcome to this tutorial. It's on BECE Mathematics Preparatory lesson. So the video is a revision video for BECE, JSCE and equivalent, and this is part 1 of the video. BECE means Basic Education Certificate Examination and JSCE means Junior School Certificate Examination. The equivalent could be Cambridge Checkpoint for junior secondary. You can also use it for those in JS1, JS2. While they come up, they can watch the video to prepare them ahead of the exam. This is brought to you by Uninab Resources. So we start with the first problem. Problem 1. What is the place value of 7 in the number 56.073? So in our solution, we have a 56.073. Our attention is to look for the place value of 7. So what we do is a form of converting the decimal number to fraction. Then under this point, we have a 1. Under the first digit after the point is 0. We place 0 under it, which means 0 is 0 over 10, which is 0/10. And under 7 we put a 0, which means this is 7 over 100. So bringing out 7 over 100, it means 700ths. And the option with 700ths is option B. And that is the end of solution to problem 1. We go to problem 2. Express 18% as fraction in the lowest form. So we'll be looking at solving the problem and choose from the given options. So 18% means 18 out of 100. So that we'll now have it as 18 over 100, and we now simplify it in the simplest form. So 18 divided by 2 gives 9, and 100 divided by 2 gives 50. We have our answer as 9 over 50 in the simplest form. And we look at the option. It's option E. So we have option E as the correct answer to the problem. That is 18% is equivalent to 9 over 50. So we go to problem 3. For problem 3, decrease 2,350 naira by 3 over 10. We are given the options. So in our solution, we have 2 ways of solving this problem. We can calculate 3 over 10 of 2,350, then deduct our result from 2,350, or we go holistically by fraction, and the whole sum is 1 by fraction, and the fraction of the reduced amount or decreased amount will be 1 minus the decreased fraction, which is 1 minus 3 over 10. And the method of subtracting fraction from 1 is just find the difference of the numerator and denominator, then maintain the denominator. So here we say 10 minus 3 gives 7, and we have our answer as 7 over 10. So the reduced amount now will be 7 over 10 of the original amount. So that's going to give us 2,350 multiplied by 7 over 10. This 0 cancel this 0. We now say 235 multiplied by 7. So we carry out the multiplication here. 7 times 5 is 35. We write 5 carry 3. 7 times 3 gives 21 plus 3, which gives 24. We write 4 carry 2. 7 times 2 is 14. 14 plus 2 gives 16. So we have it as 1,645, and that gives the reduced amount as 1,645 naira. And that is the solution to problem 3, which is option D. Now we go to problem 4. For problem 4, increase 3.5 meters squared by 12%. Give your answer as squared centimeters. So this is representing an area since the unit is a meter squared. So in our solution, we look at the percentage of the increased area. Since the area is being increased, so what is the percentage of the increased area? That's going to give us 100 plus 12%, which gives 112%. Since it is being increased, so the percentage increase plus the original percentage. In this case, the 3.5 meters squared is 100%. So since it is being increased by 12%, we say 100 plus 12, which gives 112%, which represents the increased area. Now, to calculate the area in squared centimeters, we first convert this to squared centimeters. Since it is from squared meters to squared centimeters, we're going to multiply 3.5 by 100 twice to convert it to squared centimeters. So that's going to be 3.5 times 100 times 100 squared centimeters. So this point, we remove one of the zeros here and we'll be left with 30. Our answer is 35,000 squared centimeters. That's 35,000 squared centimeters. Then we now get the increased area now, which is 112% of 35,000. So that will give us 35,000 times 112 over 100. Since 112% is 112 over 100, so 2 zeros cancel 2 zeros here. We now have 350 times 112, so that will give us 112 times 35. We keep the 0. After the multiplication, we add the 0. So that's going to give us 5 times 2 gives 10. Write 0, carry 1. 5 times 1 gives 5 plus 1, 6. So we are there. 5 times 1 gives 5. Then we're done with 5 as multiplier. We go to 3 as multiplier. 3 times 2 gives 6. And we have to write it under the 3. Since we are using 3 as multiplier, we start recording our result under 3. So 3 times 1 gives 3. 3 times 1 gives 3. Then we add up. This is 0. 6 plus 6 gives 12. Right? You carry 1. 5 plus 3 gives 8 plus 1, 9, and this is 3. So we have it as 3,920. When we add the 0, we have 39,200. So our final answer will be 39,200 squared centimeters, which represents the increased area in squared centimeters. And the available option here, that is option A. So we are done with solution to problem 4. We go to problem 5. For problem 5, an article originally marked to be sold for 6,400 was later sold for 6,080 naira. Calculate the percentage discount. Here, okay, yeah, these are the options, and let's look at the solution. What is the actual discount? We need to calculate the discount. So the discount is 6,400 minus 6,080. That's equivalent to 400 minus 80. That's 320. Yeah, that's the discount is 320 naira. And to calculate the percentage discount, this is the same thing as percentage decrease. So what you do is the discounts over original price. Original price is 6,400 then times 100%. So 2 zeros here cancel the 2 zeros. 32 can go into 64 to give us 2, and 320 divided by 32 gives 10, and 2 goes here, 1, 2 goes into 10 gives 5. So we have our answer as 5%, and that corresponds to option B. So that is the end of solution to problem 5. We go to problem 6. For problem 6, round off 2.034 to 2 decimal places. To solve this problem, here we originally have 3 decimal places. That is the number of digits after the decimal point. So we have 0, 3, 4, which is 3 digits. So this is 3 decimal places. We're interested in only 2, the first 2 digits after the decimal point, which is the 0 and 3. So we draw our line there. Since this is 4, we are going to round it down to 0, which will now give us 2.03. This has been rounded off to 2 decimal places, and the correct option here is option C. And that is the end of solution to problem 6. We go to problem 7. For problem 7, evaluate 0.386 multiply by 43 correct to 3 significant figures. In carrying out the multiplication, since we have 3 decimal places here, no decimal points, so we are going to remove the decimal point. So we now have 386 multiplied by 43. Then later we apply the decimal points to 3 decimal places. So we have 3 times 6 gives 18, carry 1. 3 times 8 gives 24 plus 1, 25. We write 5, carry 2. 3 times 3, 9 plus 2 gives 11. We are done with the 3 as multiplier. We go to 4 as multiplier. 4 times 6 gives 24. We write 4, carry 2. 4 times 8 gives 32 plus 2, 34. We write 4, carry 3. 4 times 3 gives 12 plus 3, 15. We have it as 15. We are going to add. So adding this is 8. 5 plus 4 gives 9. 1 plus 4 gives 5. 5 plus 1 gives 6. And here is 1. So therefore we now say 0.386 times 43 will give us 16598. Then we place our decimal point 1, 2, 3. We place the decimal point between 6 and 5, which is the product of multiplying 0.386 and 43. Now we are going to correct this answer to 3 significant figures. 1, 2, 3, 4, 5. We have 5 significant figures now. We are interested in the first 3. That is, we are interested in 1, 6, and 5. So we draw our line there. Since this is 9, so we are going to round it up to 1 and add that 1 to 5. So our answer becomes 16.6 to 3 significant figures. And the correct option here is option C. And that is the end of solution to problem 7. We go to problem 8. For problem 8, express 0.008634 as standard form. These are the options. All these options here are examples of standard form, but it's only one of them that will be the standard form of this 0.008634. So we solve. Finding solution to this, we have a 0.008634 in standard form. In standard form, we need a non-zero digit number before the decimal point. So that is to say, we are going to move these decimal points from this original place up till this place. So we move 1, 2, 3. We are stopping here because this is 8.634. So giving us 8.634 times 10. Since the number is 0.00 something, 0.0 something, 0.000 something, the power is going to be negative. But negative what? Negative the number of steps we have moved. We moved 1, 2, 3 times, so it's going to be raised to power negative 3. And the ones with negative 3 is only 1, and that's option D. Assuming the number is 8634 to be expressed in standard form, for example here 8634. So what we do is, ideally it can be expressed as 8364.0, which means we are moving the point between 6 and 8, so that it becomes 8.634. Then that will be times 10 to the power of 3, because when you place a decimal point here, we have 1, 2, 3 digits before the end, and we said at the end we can put point. So it is 3 steps you have moved the point between 8 and 6. So it's going to be positive 3 in this case, because this is a number greater than 1. But in the original problem we just solved, this is referred to numbers less than 1. Numbers less than 1, 0.00 something, 0.0000. So that is the end of solution to problem 8. We go to problem 9. For problem 9, express 1.57 times 10 raised to power 5 as ordinary form. This is a standard form now. So in the previous problem we express a number that is in ordinary form as standard form, and now this is a number in standard form to be expressed as ordinary form. So we find solution to this problem. We have a 1.57 times 10 raised to power 5. This is equivalent to 1.57 times 100,000, because in 100,000 there are 5 zeros. So 10 raised to power 5 means 10 times 10 times 10 times 10 times 10, which gives 100,000. So because of this decimal point, we are going to remove the decimal point and remove 2 zeros. So that will be 154 times 1000, and the method of multiplying is just to add a 0, so that we now have it as 157,000 as the ordinary form of 1.57 times 10 raised to power 5, and that corresponds to option C. And that is the end of solution to problem 9. Now let's look at if the power is negative. Take for instance, we have it as 1.57 times 10 raised to power negative 5. How do we resolve this? That's going to give us, in this case, since it is positive index here, and we multiply, and here we are going to remove this. That's going to change this multiplication to division. So we have 1.57 divided by 100,000, and here 1.57. We are meant to move the point to the left, so we just add zeros to the numbers before it. It doesn't add to the value of the original number. So what we do now, if we move this 5 times, 1, 2, 3, 4, 5, the point will be here, and this point will now go, so that our ordinary form of 1.57 times 10 raised to power negative 5 will be 0.000157, and that is that. I hope if you come across the standard form of negative index to be expressed as ordinary form, you will not have problem. Okay, let's go to the next question, which is problem 10. Express 102 thousandths as decimal. So in our solution, here this is 102 thousandths. The approach to this is the thousandths actually starts from 1. So it is not 102 over 1000. So what we do is we said 0 point, we have 102, 10 is tenths, the second 0 is hundredths, and this 1 will be what? Thousandths. So that is just the best way to resolve this problem, and this corresponds to option B. And that is the end of solution to problem 10. We go to problem 11. In problem 11, we are to simplify 13 plus 3 into 9 minus 3 times 2. Finding solution to this problem, we have a 13. We are going to use board mass, starting from brackets. So if we start from bracket, we still maintain this 13 plus 3, and what we have inside this bracket is 9 minus 3, which will give us a 6, then times 2. This bracket also will still be 13 plus 18, then multiply by 2. This is 18 multiplied by 2 gives 36. So 13 plus 36 gives 49. And the correct option is option C. And that's the end of solution to problem 11. We go to problem 12. For problem 12, what is the first digit of the square root of 86? To find solution to this problem, the perfect square close to 86 is what we are looking for. That is, we have 81 as a perfect square, and the next perfect square is 100. So this is still far away from 100. So it means the perfect square close to 86 is 81, and square root of 81 is 9. So if you are looking for the square root of 86 now, the first digit will be 9, because it's going to be 9 point something. And that is just the solution to the problem. So therefore, the first digit of the square root of 86 is 9. And the corresponding option is option A. And that's all. So we go to problem 13. For problem 13, find the smallest number by which 216 must be multiplied to make a perfect square. For this solution, 216 is not a perfect square. What number can we multiply by 216 to make a perfect square? Okay, we are going to express 216 as product of prime factors. So to do that, we have our table. 216 is divisible by 2, and 2 is a prime number, so 216 divided by 2 gives 108. 108 is still divisible by 2. This is 54, and 54 is still divisible by 2 to give 27. 27 is divisible by 3. 27 divided by 3 gives 9, and 9 divided by 3 gives 3. 3 divided by 3 gives 1. So from here, 216 is 2 times 2 times 2 times 3 times 3 times 3. So we group the numbers into 2. So I have 2 2's here. This is now up to 2 again. I leave it there. I have 2 3's here, and this is now up to 2. So these single numbers remaining are multiplied together to give the number to be multiplied by 2 1's to make a perfect square. So that we now have it as 2 times 3, which is equal to 6. And that is option D, which brought the solution of the problem to an end. And we go to problem 14. What is the square root of 1 whole number 9 over 16? We have to express 1 whole number 9 over 16 as improper fraction. So to do that, 16 times 1 gives 16 plus 9 gives 25 over 16. Now square root of 25 over 16, square root of 25 is 5 and square root of 16 is 4. And we are not leaving our answer like this. We have to express it back as mixed fractions. So that will give us 1 whole number 1 over 4. 5 divided by 4 gives 1 remainder 1 over 4. And that is option B. And that's the end of solution to problem 14. We go to problem 15. For problem 15, we have to simplify 7m plus 3n minus 9m minus 2n. In our solution, we are going to collect the terms with m and the terms with n. So the terms with m are in blue, while the terms with n are in red. So we bring them together without any change of sign. This 7m is positive, so I have it as 7m. This is minus 3m. There's no idea of changing sign. It is not moving from one side to the other. We are just collecting the like terms within the same range. This is not an equation, so there's no change of sign. And plus 3m minus 2n. So 7m minus 9m, we can just say 7 minus 9, which gives negative 2. Then 7m minus 9m gives negative 2m. Then 3n minus 2n is equivalent to say 3 minus 2, which gives 1. Then 1n, we won't say it's 1n, so we say plus n, even though we know that it is 1n, but we say plus n. Then we can rearrange this to take the negative in, so we now have it as n minus 2m, and that gives option D. That's the end of solution to problem 15. Now we go to problem 16. What is the coefficient of a in the expansion of a minus 3 into 2a plus 5? So in our solution, we are going to expand the two brackets. So we pick the first term in the first bracket, which is a. We multiply it by the second bracket. Then we pick the second term in the second bracket, which is negative 3. We multiply again by the second bracket. So we now expand. A times 2a gives 2a squared. A times 5 gives 5a. Negative 3 times 2a gives negative 6a. Negative 3 times 5 gives negative 15. So we now simplify these middle terms, which are like terms. So we now have 2a squared positive 5a minus 6a. It is the same thing as saying positive 5 minus 6, which gives negative 1. And that will give us negative a, then minus 15. So the coefficient of a now, in this expression now, a squared has 2 as its coefficient, and the constant term here is negative 15. Therefore, the number attached to a here, which is negative 1, is the coefficient of a, and that is option E. So we have done justice to problem 16. We go to problem 17. Multiply the LCM of 6, 5, and 3 by the HCF of 12, 18, and 42. So we have the options here. To find the solution to this problem, we find the LCM of 6, 5, and 3 first. So we are going to use tabular form. 6, 5 and 3. 2 can divide 6, so I go with 2. 6 divided by 2 gives 3, then we retain 5 and 3. 3 divides 3, so we go with 3. 3 divided by 3 gives 1. 3 does not divide 5, so we have 5. Then we have a 1. Then 5 goes. We have 1, 1, 1. So the LCM will be 2 times 3 times 5. 2 times 3 gives 6 times 5 gives 30. Then we go ahead to find the HCF of 12, 18, and 42. To find the HCF of these numbers, we are interested in only the numbers that can divide all the 3 numbers at the same time. So 2 can divide all of them. 12 divided by 2 gives 6. 18 divided by 2 gives 9. 42 divided by 2 gives 21. 2 cannot divide all the numbers again. We look at 3. 3 divides 6, 9, and 21. So we divide by 3. 6 divided by 3 gives 2. 3 divided by 3 gives 9. 21 divided by 3 gives 7. So since there's no number that can divide 2, 3, and 7, so we say HCF is 2 times 3, which gives 6. Now LCM multiplied by HCF will be 30 times 6. 3 times 6 is 18. So adding 0, we have 180. And the option here is option E. So that is the end of solution to problem 17. We go to problem 18. Find the LCM of 5x squared y and 3xy squared. To find the LCM, just like we did in the previous problem, we have 5xy and 3xy squared. We start with the numerical terms. 3 divides 3 here, so we go with 3. 3 cannot divide anything here, we retain them. So 3xy squared divided by 3 gives xy squared. Then we go with 5. 5xy squared divided by 5 gives x squared y. Then we bring in xy squared. Now we go with x. X squared y divided by x gives xy. This will give us y squared. X divides this again to give us y, and this is y squared. We go with y. Y divided by y gives 1. Y squared divided by y gives y. And finally we go with y, which gives 1, 1. So the LCM now will be 3 times 5 times x times x times y times y. And 3 times 5 gives 15. X times x gives x squared. Y times y gives y squared. Therefore, the LCM of 5x squared y and 3xy squared is 15x squared y squared. And that will give us option D, which is the end of solution to problem 18. We go to problem 19. What is the LCM of 12pq and 4pq squared? To find our solution again in a tabular form, we have a 12pq and 4pq squared. We start with the numerical terms, so we have a 2 dividing 12 gives 6pq, 2pq squared. Now 2 goes again, we have a 3pq and pq squared. P divides both of them, so we have it as 3q and q squared. Q goes, this will give us a 3 and a q. We are stopping here since there's nothing that can divide both 3 and q, so that the HCF now will be 2 times p times q. 2 times 2 gives 4 PQ. And the HCF of 12PQ and 4PQ squared is 4PQ. And that is option C. And that's the end of solution to problem 19. We go to problem 20. Problem 20, express 3 over 2x plus 2 over 3y as a single fraction. Here we are going to look at the LCM of the two fractions. To get the LCM of the two fractions, we multiply 2x and 3y, so that we have the LCM of 6xy. 6xy divided by 2x will give us 3y, and 3y times 3 gives 9y. 6xy divided by 3y will give us 2x, and multiplying it by 2 gives 4x. And that is all. We cannot simplify further, so the option is option D. And that's the end of solution to problem 20. We then go to problem 21. Problem 21, factorize px minus qy plus py minus qx. In the solution to this problem, we are going to rearranging, because the first two terms nothing is common, the last two terms nothing is common. So let us group the positive terms and the negative terms together. So we have a px plus py. From here now p is common, and negative qy and negative qx. So q is also common here. So we pick the first two terms. P is common there, so we have p. Px divided by p gives x, and py divided by p gives y. Then we go to the last two terms. Negative is common to both of them. Q is also common. So qy divided by q gives y, and this negative divided by negative gives positive x. And we should know that x plus y is the same thing as y plus x. So we pick the common brackets, which is x plus y. Pick what is outside the first bracket and what is outside the second bracket. So we have succeeded in factorizing this expression, and x plus y p minus q, and this is option C. So we have done justice to problem 21. We go to problem 22. Factorize completely 8x minus 18xy squared. In factorizing this, we first look at the coefficients. This is 8 and 18, so 2 is common between 8 and 18. This is x here, this is x here, so 2x is common. So what we do is 8x divided by 2x gives 4, minus 18 divided by 2 gives 9, divided by x gives 9y squared, and that is all. 4 is a perfect squared, 9 is a perfect squared, y is a perfect squared. Well, we can still factorize further. This is difference of two squares, so that is 2 squared minus 3y all squared. So this is difference of 2 squared now. So we have 2x into 2 plus 3y, 2 minus 3y. With this, we have completely factorized this, and we look for the option 2x is not here. Oh, this is positive, positive. No, this is option C. That's option C, and that's the end of solution to problem 22. We go to problem 23. Solve 7x is equal to 3 into 2x minus 3. So here we expand the bracket on the right hand side, So that is 7x equal to 6x. 3 times 2x gives 6x. 3 times 3 gives 9. So that's 7x minus 6x is equal to negative 9. Bringing this 6x to the left hand side, it changes to negative. So that will give us x is equal to negative 9. 7x minus 6x is x equal to negative 9. And that is option A. That's the end of solution to problem 23. We go to problem 24. Find the value of A in the equation 3a plus 2 all over 5 minus 2 minus a all over 4 is equal to 5. To solve this problem, we need to remove the fractions, and to remove the fractions, we multiply every term by the LCM of the denominators of the fractions. So the denominators here are 5 and 4. LCM of 5 and 4 is 20. We multiply the whole of this fraction by 20. That gives 20 into 3a plus 2 all over 5 minus 20 into 2 minus a all over 4 is equal to 20 into 5. Remember, we are multiplying every term by 20. 5 goes here 1, 5 goes here 4, then 4 goes here 1, 4 goes here 5, and that's going to give us 4 into 3a plus 2 minus 5 into 2 minus a is equal to 20 into 5. Then we now expand these brackets. 4 times 3a gives 12a, 4 times 2 gives 8, negative 5 times 2 gives negative 10, and negative 5 times negative a gives positive 5a is equal to 100. Now simplifying the like terms, 12a plus 5a gives 17a. This is positive 8 minus 10 gives negative 2 is equal to 100. So we say 17a is equal to 102. If you take this negative 2 to the right hand side, it becomes positive. 100 plus 2 gives 102. Dividing both sides by 17, a is equal to 6. 6 times 7 is 42. 6 times 1, 6 plus 4, 10. 102. A is equal to 6, and that is option B. So we are done with problem 24. We go to problem 25. When 8 is subtracted from 5 times a certain number, the result is 1/3 of the number added to 6. Find the value of the number. So in our solution, 8 is subtracted from 5 times a certain number. First, let the number be n. Since the number is n, 5 times n, that's 5n. 8 is subtracted from 5n, that's 5n minus 8. The result is 1/3, that is n over 3 of the number added to 6. This is the equation connecting the statements. 5 times a certain number, 5n, 8 is subtracted, minus 8. The result is 1/3 of the number, that's 1 over 3n, which is equivalent to n over 3, added to 6. 6 is added. So we now find the value of the number. To find n, we need to remove this fraction by multiplying through by 3. Multiplying 5n by 3, I have 15n minus 24 is equal to n plus 18. So 15n minus n is equal to 18 plus 24. 15n minus n is 14n. 18 plus 24 gives 42. It can't be 2, n cannot be 2, 3 times 4, 12, yeah. So n is equal to 3. So the number is equal to 3, and that is option B. And that's the end of solution to problem 25. We go to problem 26. Which of the following inequalities is represented on the line graph? Okay, we examine the line graph. So it is x, and since the arrow starts from 6, we have a 6. The arrow is pointing to the right, which means the inequality is greater than. So the inequality represented on the line graph is x greater than 6, not greater than or equal to, because this end of this arrow is not painted. So the option is D. So we have done justice to problem 26. We go to problem 27. Represent the solution of 5 into x plus 1 less than or equal to 3 into x minus 1 on a line graph. So, and our solution, we expand the brackets. 5 times x gives 5x. 5 times 1 gives 5. 3 times x gives 3x. 3 times negative 1 gives negative 3. Collecting the like terms, 5x minus 3x. This is coming to this side, it becomes minus, less than or equal to negative 3 on the right hand side originally. Bringing this positive 5 to the right hand side, it becomes negative 5. So simplifying this, this is 2x less than or equal to negative 8. Negative 3 minus 5 gives negative 8. Dividing both sides by positive 2. This is positive 2. The sign will still be maintained. We have x less than or equal to negative 4. So representing this on the number line, we have a number line. We are starting with negative 4. And since it is less than or equal to, we shade the circle there. And the sign is less than or equal to. Draw a line across it. We have our arrow pointing to the left, and this is the number line of this solution of the problem, and pointing to the left, and that's option C. That's option C. And that's the end of solution to problem 27. We go to problem 28. Given that x is an integer, give the 3 greatest values of x if 3x minus 4 greater than 6x minus 17. So we find solution to the problem. 3x minus 4 greater than 6x minus 17. Collecting the like terms, 3x minus 6x greater than, we have negative 17 plus 4. This is negative here, coming here, it becomes positive. 3x minus 6x gives negative 3x greater than negative 13. Since we are going to be dividing both sides by negative, this sign will change. So we now have x less than 13 over 3. The negative will cancel out negative. So we have it as x less than 4 whole number 1 over 3. We need a number line to help us get the values of x that are integer. So this is between 4 and 5 this side. The arrow is pointing to the left. All the whole numbers. An integer means a whole number, positive or negative. So we'll be having the 3 greatest values of x as 4, 3, 2, and since we are interested in only 3, and that is option D. So we go to problem 29. 5 times a certain number is not greater than the number added to 12. Find the range of values of the number. So in our solution, 5 times a certain number that is 5x, if you take x to be the number, is not greater than, maybe then it is less than or equal to the number that is x added to 12. So we have 5x minus x less than or equal to 12. This is 4x less than or equal to 12. Dividing both sides by 4, we have x less than or equal to 3. X less than or equal to 3, that is option B. So we go to problem 30. Which of the following is not correct? 4 greater than 3, correct. Negative 9 less than negative 3, that's correct. Negative 7 greater than negative 15, that's correct. Negative 3 less than 0, yes. E, 0 less than negative 3, no. The option here is E. E is not correct. And this is the end of this part. Thank you for watching. Like and share this video. Remember to subscribe to our channel. Check the description section of this video on our YouTube channel to get links to part 2 of this video. Until we come your way again, goodbye.